Hey guys, I hope everyone is doing well. I sure do miss seeing you guys as life is pretty monotonous these days. I wanted to give you some notes on an application of Trig, which is an extension of what we have been doing. And you'll see in front of us, we have a bunch of reciprocal identities, just remembering that sine is the reciprocal of cosecant, cosine is the reciprocal of secant, tangent is the reciprocal of cotangent, etc. And here they're shown again. And then remembering tangent is sine divided by cosine, and remembering cotangent is cosine divided by sine. There's some other identities that you need to know, and they are extremely important, namely this one. And I'm not going to go through the derivation of the proof right now, but sine squared x plus cosine squared x equals 1 is super important. You can derive these other two by taking the original, if you ever forget, and just divide everything through by either sine or cosine squared. And when you do that, sine over sine is 1, cosine squared over sine squared is cotangent squared, 1 over sine is cosecant squared x. So you actually end up with this. If we would have divided everything by cosine squared, we would have ended up with the second one. But these are pretty important. So what we're going to do is look at verifying identities. And when we do that, we are basically only touching, important, that's supposed to be a star, only touch one side of the equation. So these are very much like puzzles. All right, so in this first example right here, we are trying to verify that secant x times cotangent x equals cosecant x. And usually you want to start with the more complicated side. So in this case, we are going to use strategy number 1, which is to change all of our values to sine and cosine. So secant is 1 over cosine x, and cotangent is cosine x over sine x. And we are trying to prove that this equals cosecant x. We notice here that the cosine x's will cancel, and we are just left with 1 over sine x. And we're still trying to prove that that is cosecant x. 1 over sine x is cosecant x, so we can put a check mark, and we have proved that the left side equals the right side. So that is the goal of what you're trying to do. All right, so if we tried this example, cosecant is 1 over sine x, tangent is sine x over cosine x, and we're trying to prove that that is secant x. Just like in our previous example, here the sines cancel and we're left with 1 over cosine x. And we're asking, does that equal secant x? And it does. Secant x equals secant x. So that's good. That's what we're trying to prove. This goes back to geometry when you learned about proofs and how everything there worked. All right, same thing here. We're going to verify in this example sine theta tan theta plus cosine theta equals secant theta. So we're going to start with the more complicated side. Sine theta, tangent theta is sine theta over cosine theta, and we're trying to prove that that equals secant theta. So this gives us sine squared theta over cosine theta, sorry, I forgot this little guy right here, plus cosine theta. We're trying to prove that that equals secant theta. We need a common denominator here, so this guy is going to get multiplied by cosine theta over cosine theta. And when we do that, we have sine squared theta plus cosine squared theta all over cosine theta. We're still trying to prove that that equals secant theta. This is a Pythagorean identity. This whole thing equals 1. So it comes down to 1 over cosine theta equaling secant theta, And that is very true. Secant theta equals secant theta. All right, so this is all about getting a common denominator. This example will be the same thing. Okay, it's going to look exactly like the one before. The second strategy that we're going to look at in the first part of this lesson is factoring. And when we look at the left side in this example, there are two things that look the same in each part of this equation, and it is a cosine of t. So we can take that cosine of t and factor that out. All right, and inside, if we remember, cosine squared theta plus sine squared theta equals 1, then 1 minus sine squared theta equals cosine squared theta. So we can manipulate these identities, and we're going to use this right here. So cosine t times cosine squared t equals cosine cubed t. And that is true. Cosine cubed t does equal cosine cubed t. So that works out just fine. Again, in this problem, each part has a sine t, and we're left with 1 minus cosine squared t equals sine cubed t. Looking back up to our identity, cosine squared theta plus sine squared theta equals 1, and we have 1 minus cosine squared theta, so that will equal sine squared theta. All right, and we can use that here. Sine t times sine squared t equals sine cubed t. And that is what we got. Sine cubed t equals sine cubed t. And we're going to stop there for today's part, and then tomorrow we'll pick up with the other strategies. But for now, you're just going to work on converting everything to sine and cosine and factoring and see how that works out for you. All right, good luck. Let me know if you have any questions.